everybody. It is Mike Levin on Friday, March 12th, 2021. And today I thought I'd do another summary of my recent videos, which includes my prior video, which had a summary of my recent videos. So bear with me as I look at it from another direction, through another lens, and plan my next step of what I want to talk about, which still remains fundamental tooling that I want at my fingertips when I start any project. And this has included a high-performance, local, persistent data store, cache, if you will. And there's a whole bunch of interesting related discussions here, because I've been doing this forever through the pickle and shelf API. You put pickles on shelves. And having local persistent dictionaries in Python has forever been a no-brainer, so long as it wasn't user-provided input that you were using this on, because unpickling executes whatever it finds. So you don't want to ever pickle or shelve any user-provided input. But when it's your own stuff or API calls, it's great. It's wonderful. And so this kept me from really playing around with SQLite. That comes included with a Python standard package, and I've been meaning to try it out for the longest time. But the problem is, having been there, done that, I hate SQL. I think the English-like implicit language, implied, like HTML and other markup and attempting to be natural flowing spoken languages, it really has a lot to be desired with structure and brief, elegant statements. Everything in SQL seems to be large and ugly, and all the techniques to make it not so seem to have SQL implementation dependencies, like use of functions. So, SQL I've never found to be all that cracked up to be the big thing, it's talked about. Well, same with HTML. So we live with a whole spate of 80-20 rule tools, with 20% of the effort anyone's willing to put in, you get 80% of the benefit people are looking for. So you get a whole lot of things. You get regular expression pattern matching. There could be much better pattern matching, and I believe with Python 3.9 there is. There's this thing called Snowball that's been out there for a while. I forget what world it came from, maybe Pascal or something like that. But there was a package for pattern matching that was just much better than regular expressions, but for P in the pool of tech reasons, regular expressions won. I think it's because of their inclusion in Perl, the pathologically eclectic listing language or rambling language. So there's all these acronyms, and they really do some serious channeling, some serious revealing of the spirit of things. And Perl is being purged out of most distributions of Linux now because it's pathologically eclectic and no one really likes to use it. No matter how cunning of a language you can use in Perl, it is nobody's favorite language, but it was for a long time everyone's common language. It was the biggest L in the LAMP platform. Linux, Apache, MySQL. I even have to think that now that it's been all by Oracle, I stumble over it. And P for Perl, usually. And it was a different age. It was the age of CGI. I don't want to go on too many sub-discussions here, but people crave something better, and they're not willing to wait for perfection. So when there's a 10x improvement, it will be accepted in such unbelievably miraculous things such as purging Perl from most Linux distros has almost entirely occurred by now. This is, unimaginable to people like me who've seen Perl used so extensively as an alternative to Unix shell scripts, which are even worse in their backwards if statements and backticks. It's just, no one likes to do it. And in fact, there were so many people who didn't like to do it that when the time came to move to config files, it was one of the biggest almost schism splits in the Unix world. It was like what the Walrus operator was to the Python world. Systemd is to the Linux world. Now Linux has finally embraced Systemd, a subsystem and permissions and user management and execution context manager, scheduler, task respawner, daemon oversight task. A real low-level piece of the operating system that has such high privileges to monitor things. And it is driven by config files like .ini, or I forget what they are. They might be they're not .xml, but they're a standard, and they're easy to edit. They're like a proto-JSON, name value pair stuff mostly. And so instead of having to write bash script files, I should say Unix script, because bash is even yet a step more sophisticated, and it relies on a shell in order to run those scripts. So the discussion keeps getting deeper and deeper, but the bottom line is that Perl replaced shell script and Python is replacing Perl, but it's a combination of Python and configuration files that just need to be in certain locations for the systemd magic to step in and do its thing. It's, Linux by prescription, and there were plenty of folks who felt that violated the spirit of Linux, and it should continue to use its initd system, under which you just write a bunch of bash scripts and you put files in locations and give them the right permissions, and it's going to control your startup procedure, and it's going to give you interfaces to start and stop and restart services. But it's so laborious, and it keeps those tasks very much in the hands of the elite, the ivory tower, old school Unix style sysadmins, which I'm sure have their fair representation in the Linux world. But ultimately the systemd people who said, get root and put this file here and that file there, where this equals that and that equals that, and you're golden, no backward ifs. And only, I think, like Arch Linux, which is always an old school holdout, there's a lot of people who don't feel they need a Linux desktop, people who don't feel they need a GNOME or a KDE user interface, say, well, if I don't need all that user interface stuff, why am I even using Ubuntu? Or why am I even using KDE or Mint or fill in the blank when I could just be using a stripped down just enough version of Linux to get the advantage of very small surface area, the minimum number of files in location, without going overboard to a Linux like TinyCore. I also use TinyCore Linux. I actually released a version of Linux, which is a respin of TinyCore Linux that'll run on your desktop in a little box without any install or anything. No system, no admin privileges, and you delete it and it's gone. It's a little Linux. I call it Levinix. And that uses TinyCore Linux, which takes the stripped down concept to an extreme. In fact, it doesn't even include the whole set of traditional Unix commands, which are cloned and called Linux GNU command set. So when we say Linux, we mean the stuff to just get the machine booted, the Frankenstein moment of pulling the switch and instruction saying it's alive. And there's a lot of hardware-specific binaries in the picture. There's a location that has a writable boot process that hands control over to the next thing and hands control over to the next thing. And everything generally works that way. You hardly ever see any of it. And I guess what I'm talking about here is I get the ones that go to desktop take it a step further. Control, you used to see the command screen X. People from the Windows DOS days, the days before Windows, the days of DOS, will remember that you had to launch Windows after booting into DOS. So there was always this terminal-like interface that booted first. There didn't have to be. There's this impression that there has to be, because so many systems you'll be exposed to somehow boot to a stripped down, they don't even call it a shell, it's a command line interface. Amiga had the CLI, the command line interface, that ran an operating system called Intuition. And it was very intuitive, and it was very based on Unix concepts, and it's what I got familiar with first. And he's still one of the funniest posters in Facebook. I am in connection with R.J. Michael, one of the fathers of the Amiga computer, something that did everything people are enjoying today as the modern tech revolution before today. The future was then. Back in the late 80s, early 90s, before the web hit, there was a wave of time where everything happened first. Free and open source software was happening in the shareware community, run on BBSs and the FidoNet. And, a couple of university people here and there and some corporate workers might have had an account on something called the internet through net access or some other local provider where you might expect to use Gopher or one of these other crazy protocols that was out there. That wasn't a web browser. It was the internet without the web browser. Crazy times. But during those times was the Amiga computer. Ahead of its time in so many ways, except it was an expression of the time so hardwired that it could not evolve. Or, more honestly, it got put in the hands of stewards who could not evolve it. It went from the original inspired Atari hardware engineers, quote S, because it's really original Atari hardware engineer, the guy who did the Atari 2600, the VCS, some might remember it as, original home game machine console that took the world by storm. Nolan Bushnell, the creator of Atari. Oh, those were the days. Well, one of the people on that team was J Miner, and he designed the custom chips that went into the Atari 2600, which were another example of making the silicon of the day sing and dance at a very low price by pulling lots of bitplane tricks, for example, which is the opposite of today's, deep bit graphics, where the processors are so fast it can animate photorealistic images at 4K. It was not always that way, ladies and gentlemen. Once upon a time, it was difficult to animate 640 by 480 with 16 colors. That was the Amiga's high-resolution mode. 640 by 480 with 16 colors, and it was very, very limited because there was so little memory in these systems back then. And if you could make that look smooth and cool, you'd call yourself lucky. And one of the main tricks was to cut down the number of bit planes you were using. Stuff that isn't done so much today with all these graphics co-processors. And the Amiga had graphics co-processors too. It basically pulled every trick to give you a preemptive, high-performance graphics multitasking system that had an underlying very Unix-like command line interface running a operating system called Intuition, written by a guy who I met a couple of times. He wouldn't remember me. I went to the Commodore conferences in the early 90s. CES, Comdex, I was at the booths. I was working the booths, but I got around and I saw all the stuff that was up and what Commodore did to the computer industry in 1987, 88 when it came out, and everyone was like, oh, this is it. The future of computing is written, and it's called Commodore because this Amiga is some pretty amazing stuff. That turned around real fast, and everyone likes to blame marketing because no one stands out as really distinguished in the Commodore marketing circle of people. You're not going to look back and go, oh, that Harry Copperman was such a brilliant marketer, everyone remembers him. But they will look back at the engineers with fondness and go, oh, that Dave Haney, he made those Zorro slots, and autoconfig was really ahead of its time, as ahead of its time as the Amiga before it. And this is true. And it enabled things like the video toaster and a second wave of legendary hardware to make the Amiga sing and dancing going into orbit. It was so badass. I had a Amiga 2000 decked out with, I think, an 030 processor. I never got up to an 040, 68040 Motorola chip. I think I had an accelerator to get me to maybe 030, and I had a video toaster thrown in and a Mandela card for virtual reality, interacting with what they call augmented reality today. I was doing this in 91, maybe even 89, 90. And I gave that to a buddy of mine. He still has it. Hey, shout out to Steve Elsner. One of my various potential partners in crime over the years. Never really panned out, sorry, Steve, but I get it. When you have kids and settle down and stuff, you really don't focus on these nutty projects and these obsessions that could, become, successful ventures and businesses. I went to school with a kid who became one of the Forbes top 40 richest people in the world, or at least the United States. I don't know whether it was a sub-list. And subsequently, he's not on that short list anymore. He's still one of the big ones, but he was a .com, taking out into the stellar sphere. I went to school with him. I almost got in a fight with him. We didn't show up at the same location for an I Call You Out fight, and that's my history with Mike Rubin. I also went to school. Police lights just popped on behind me. I don't think it's for me. I see them pulling someone over. This will be a very interesting video. What else? Where am I going? Yeah, so through all this time, I was learning this very specialized knowledge. This video might become the story of falling in love with a fragile garden. A beautiful, elegant statement of the best computing of the day that could be expressed. And it was slipped through as, let's develop a computer, but it was really all the techniques of the game machines of the day, given a keyboard port and a disk drive port so that you could upgrade it to a computer, and a mouse port. I guess those were the three things. You needed something you could load software from, the disk drive. You needed a thing to type on, a keyboard, and you needed a mouse because the Mac came out even before this. We're talking 1984 was the first Mac, the 256K, not even a megabyte, right? 256K. So there's 4 of those in 1 megabyte. There's 1,000 megabytes in 1 gigabyte, and we measure things still a lot in gigabytes, but that measurement is going up to terabytes these days. So that times 10 exponential increase implied by Moore's law is, has gotten us to where we are today, where the phone I'm recording this on it might as well be a supercomputer by the standards of those days. We are living in a very, very privileged time. I'm pre-digital. Not really pre-digital, but Unix was invented in 1970 by Kenneth Thompson, I don't know, 30 miles away from where I was born in New Jersey. And, there's that whole Princeton connection to this work, but I think most of it was in AT&T. It's not even, it's Bell Labs, it's Ma Bell. There's a Ma Bell facility, one in New York City too, I think. So this was New York, New Jersey, Princeton, and computers were being brought down from room size to refrigerator size, and operating systems were being brought from, written for just one piece of hardware to maybe kind of portable, but the laws governing it were not determined yet, and there were these very large projects that had later evolved into Multics that scared people like Ken Thompson and Dennis Ritchie into saying, hey, here's Unix, the most opposite we can make, just chop off, and you have Unix. And it's the least operating system that you can port across different hardware to do the most things using this certain philosophy where everything's a file. You can read and write the files. You know how to use that kind of API, right? You write a text file. You can do this little trick with these vertical bars. We call it piping. You make your command short with a lot of different arguments that you can feed it so that you master the ls command to list directories, and you master the cd command to change directories, and then you can write these little script files that chain up the commands, and you can put those in a text file and you can execute them as a shell. And there you have an operating system and a system for automation. We call that Unix. That's great. You belong to Ma Bell. You belong to AT&T. That's intellectual property. Oh, but everyone knows how great this stuff is, so everyone's spinning a proprietary version. The Unix Wars, and I was working for Commodore during the Unix Wars. It was a very strange thing, and I saw it from a very strange perspective. So I was much more in the world of home computers, which were gaining the power of what we called workstations, the Sun Spark workstations, the Apollos, the Silicon Graphics, which we all looked at and coveted. And some of these were really weird machines that weren't even Unix underneath. They came from another world, an MIT-inspired world of the Lisp programming language, where the hardware was optimized to create self-modifying code that turned out to be great to bring dinosaurs to the movie screens and not much else, when the battle was won in economies of scale. And that meant the x86 processors from Intel, to the point where Apple switched from the Motorola Heritage 68000 processors, which were also, by the way, in the Amiga computer, and some of these early workstations used this family of Motorola processors. Motorola, people who invented radio and stuff, got into microprocessors just like a lot of those early companies did, and had their whole own desktop platforms where they did all the silicon. Sun is always the trophy example, but I believe Hewlett-Packard was doing it at the time. The Apollo might have been theirs. There were a few strange things out at the time, and some of them were called Lisp machines, and those were the ones that were not Unix. It was that bizarro alternative world. Very powerful. And as much of a bizarro alternative possible history of computing as the Amiga was, because the Amiga was very much in the lineage of Unix by that time, because, and chime in if I have any of these details wrong, but R.J. Michael, someone who I think Jay Miner and his partners brought in to handle the software part of this picture, was inspired by Unix, that a lot of people learned by this time, because there is the Berkeley system distribution, which, while legally encumbered, was widely distributed. by this time, so a lot of people saw this stuff and understood its advantages over proprietary systems like Windows. And even though, and DOS for certain, IBM systems is what the competitors, the proprietary competitors were at this time. And even though the advantages of a free and open source, and there wasn't even those language, a free operating system was apparent, it did not happen to Unix till much later. And when it did, it happened to a version of Unix that never really enjoyed the great groundswell of support and embracing as Linux does to this day. So, with the exception of the Mac and iPhones, Unix is kind of like a gone, dead operating system. It might have embedded proprietary versions of it in a lot of things, but more and more the Linux kernel is being used. QNX is one of the small proprietary embedded Linuxes. There's others like it. Things like TinyCore, that version I talk about, works a lot like an embedded Linux. If you want a little taste of the embedded Linux experience, say in volatile Linux core, that, you know, you can write to all you want, but you're really writing to something in RAM and it goes away once the hardware's power cycle to the hardware. There's none of that instant on disk cache of today's things that blurs the line between on and off. And when she was off, everything was gone. So Linux won because Microsoft is now including a Linux kernel with Windows, and it's so easy now to get Linux running side by side with Windows, although you do have to turn on the hardware-enabled hypervisor or supervisor to have it work, WSL, Windows subsystem for Linux 2. And then you can just get Ubuntu from the Microsoft Store and just like have Linux running on your Windows machine, just like it's opening a command prompt or a PowerShell, but it's a whole legit instance of Linux. So Linux won. The version of Linux that was chosen was not the IBM schism that we know today as Red Hat and Fedora, and I forget where CentOS fits in. CentOS may be under that branch, but it's a lot of enterprise Linux, it's a lot of highly paid consultant work, a lot of support programs. And then there's Debian, which works differently, or I guess did work differently back in the day, but the behavior now of things like the Red Hat Package Manager, RPM, and the Yum interface versus this apt-get and the Synaptic interface to the Debian Package Manager, they've pretty much fulfill each other's functions now, which in the past they did not do. The Remote Package Manager, RPM, or otherwise known as part of Real Unix and the POSIX standard, is only a way to retrieve packages that you want to install, and to install them. It does not have dependency, or it did not in those days have dependency management and the ability to say, oh, what you're trying to do is no good with that mix of components. You've got to change it to be this and that's a proven solution. So this idea of formulas and proven solutions that you see again in Homebrew on the Macintosh, the way they're Unix, the way they're, free and open source Darwin, but somehow still proprietary feeling Unix deals with not having a great software repository like Debian, because Debian stepped forth and said, let's solve this problem, and then got backed by some of the greatest superheroes of tech. Again, I said this on prior videos, but if you're trying to sort the good guys from the bad guys in tech, and people like Oracle's Larry Ellison is in the bad column, and people like Guido van Rossum and Linus Torvalds are in the hero column. And people like Steve Jobs land somewhere in the middle. I am more than happy to use free and open source software like Unix to base my product on, so long as I can build a proprietary closed ecosystem on top of it. And sure, we can use as a marketing tool that it runs Unix underneath, and you can just open a Unix terminal. See, there it is. All that comp sci stuff you learned in school is what Macs are built on. And so you have an unholy alliance now between the comp sci dweebs who are happy to get real Unix at a relatively low cost. Even at Max Premium, it's low cost compared to other ways to get Unix running on a machine at home, especially back in those days. It was hard to get Unix running with like a lot of driver support to have an actual good experience. But then you could just get a Mac, a machine with this wonderful, world-class hardware build, and open a terminal. It was a no-brainer. Comp sci people loved Macs, and the art people still loved Macs because the Mac versions of things were always better until Apple turned on Adobe, and Adobe turned on Apple, and back and forth, and so it goes to this day. And now Apple's getting themselves off of the Intel processors and onto today's version of what you might call a RISC chip from out of the UK. That's in the spirit of MIPS, which is an MIT open source reduced instruction set command inspired processor that drove some of the desktops, some of the workstations of the 90s, of the late 80s and 90s. There was a MIPS machine, I do believe. So this heritage of Lisp as your low-level operating system language, the same way C is the low-level operating system language of Unix and Linux, Lisp is that to MIPS hardware, which was powerful early hardware doing the graphics of early computer graphics, especially on TV, but also, in the cinema too. And most of that went dead because x86 and economies of scale and Moore's Law, until recently when mobile showed us there could be a better way. Mobile showed us that if you make your stuff highly proprietary and put in only the metal you need for the functions that are in the phone, your battery will last longer and you'll have higher profit margins and you'll turn yourself into one of the richest companies in the world. So, like so many other things in tech, style counts. Style in product design, style in optimization, style, pedantic attention to detail. That's Steve Jobs' great contribution. Many people copy this. The System D that I bring up from time to time, which is kind of like a supervisor for Linux, was inspired by the equivalent in the Apple world, because Apple had to solve all these problems of how does this work, not only on the Mac system, which was Unix by that time, but on the iPhone, which is Unix down underneath too. So you got two Unix systems, one living in the mobile world, one living in the desktop world, making profits for Apple hand over fist out after a miracle comeback play after Steve Jobs was ousted from Apple in the early days. He went off, he did the Next computer, he dabbled in Smalltalk and Display PostScript and a bunch of other innovations that, were the best of breed in those early workstation days that he wanted to bring to this pristine machine that human hands never touched. And it was a failure, but John Scully's cheap or not cheap, they were very expensive, but poor color Macs that were losing the economy of scale race with x86, it just couldn't do it. So Apple begged, Jobs came back. He took over the music industry for a while and pulled off some miracles with the Mac platform, rebasing it onto Unix, using what he learned from Next, making OS X, a lot of Next OS's inspirations. And time and time again, Apple has the innovations that the rest of the industry copies. And System D managing tasks on Linux is no different. So when I tell you that in my tutorial videos we're working up to stepping in and taking control of Linux through System D, what API? System D. System D is the primary API we will be working with under Linux, because after that it's Python. We go from Linux boot to Python control because config files put in the /etc/system directory, might be System D, I gotta check my facts, put in such and such location will give you a Python script, a .py file, run as a background system daemon, however you pronounce that thing, with its start, stop, restart, standard APIs you need for a service, instructions for how frequently the operating system should check that it's still running, how frequently System D should check that it's still running, and respawn it. So if you create some Python .py file that actually has a syntax error, it will be attempted to be run every 5 seconds. Hardly a chore for a modern computer, even a Raspberry Pi. I might get one of these new Pis. There's this new $5 Pi. I forget what it is, but I think it's after the Pi 4 series. But they're becoming quite the enterprise. A lot of that original spirit of the 8-bit world has been brought back by I wish I could remember, but the founder of the Raspberry Pi Foundation, who worked, by this time he's probably a wealthy person, for Broadcom. So he worked for one of the people who make the embedded blobs that make your video graphics great. It has subsequently been open sourced, free and open sourced, down to those video drivers. So the Raspberry Pi is a pretty awesome platform because the graphics that drive it are high-performance Broadcom technology that have been contributed to the free and open source world. Looking for good guys? Look at the people behind the Raspberry Pi. Very good people. I mean, they're turning it into a lucrative little enterprise now, but still the white hats of tech, right along with Debian, Ken Thompson and Dennis Ritchie, Linus Torvalds, Guido van Rossum, Larry Page. There's a lot of them. Did I say Larry Page? Larry Wall, there's a Freudian slip. Larry Page is proprietary, whole different story. But there's Larry Wall, the cunning linguist, who's behind the Perl programming language. He's one of the good guy heroes. He made Linux, and I guess Unix as well. I guess those scripts, the replacement of Unix scripts with Perl happened in the Unix world as well, I believe. There's traditions here. There's all these different traditions steeped in things like MIT. I guess you hear the term media center more, but back in those days, they were the time-sharing people. The incompatible timeshare system, ITS. I think I actually got it right. I don't know where I pulled that out from. But when you're talking about crazy alternative technology worlds, what could have been Unix? The answer is ITS, the incompatible time-sharing system. And what could have been C? The answer is Lisp. And where did that come from? If, Unix came from Ma Bell, Lisp and ITS came from MIT. And, oh my God, the guy's name, I can picture him in my head, one of these Papa Smurf, Grandpa characters, is behind it. And also in that tradition is the people who reverse engineered all the individual Unix commands and released it under a groundbreaking, a revolutionary software license called the GNU license, or GSL, the General Software License. GSL under GNU. GNU is not Unix, so you got GNU is not Unix commands, CD, LS, but reverse engineered versions released under a software license called the General Software License that set the grounds for Unix becoming free and open source, although that Frankenstein moment, low-level kernel, all the stuff that knows about the hardware, was not ported. It's, arguably much more difficult to do that intimate, low-level knowledge of the hardware stuff than it is to do high-level language stuff. Higher-level language stuff like the commands. The OS commands like CD and LS are high level compared to like getting a disk drive working, getting your keyboard working. So all that low level hardware stuff is tough to do in the first place. So that's really what Linus Torvalds brought to the picture. At the time, I forget who was behind it, but BSD, which was legally encumbered because it leaked from out of Bell Labs by probably Ken Thompson, traveling around. And it was reverse engineered in its entirety in the form of FreeBSD, which is still in use out there. And, you can get desktop operating systems for that. You can run like the GNOME, desktop on FreeBSD, so really having Unix underneath, and there's software repos. But the software repos on FreeBSD feel a lot more like homebrew on the Mac. It just doesn't feel as mainstream as supported as the Debian repo, which is also the Ubuntu repo, which so expertly deals with all those low-level driver problems such that everything but the latest is supported. It's a shame then that the latest is what you can get for like $800 to get this high-quality laptop with touchscreen and stylus and all the exact stuff that you need, modern, latest, up-to-date driver support that isn't really always in even the Ubuntu world. Okay, so that sets the stage for one of the reasons why I'm still on Windows. But some of the commenters on my YouTube videos are surprised that I'm still on Windows. Well, you are mainstream. You can buy games for your kid. You don't have to deal with multi-boot environments, booting into different operating systems. Now that Linux runs side by side with Windows, you want Linux, you're there. You want Windows, you're there. You want Sims installed, you can install it. You want to run the most tweaked out, assured to work well version of the Anaconda install, you got it. You want to use the best of the Linux toolchains, development toolchains, and never have to deal with backslash weirdness of DOS, and only ever deal with the most mainstream of Linux these days. Because interestingly, I think this is one of the subtopics I got diverted from, the Debian branch, which is real white hat people, is what won, because Ubuntu is derived from the Debian branch. And Ubuntu is the version that Microsoft chose to make available really easily in the Windows Store for free. That means big deals were cut between Microsoft and the company who makes Ubuntu called Canonical, that has a bizarro Steve Jobs character in the form of Mike Shuttleworth in charge there, who has become much more low profile. He might have been involved in some sort of scandal, but a lot of the things that he was a driving force behind, like this Unity operating system, Unity, we're talking about the desktop that gets slapped on top of the underlying GNU Linux. So you got enough to get your machine booted. That's Linux. That's the Linux kernel. Then you got enough to have a type-in command line interface, and that's called the GNU part of it. So together it's GNU Linux, and it's still just type-in headless Linux. So on top of that, you got the desktop windowing operating system. And there's low-level ones of those, known as X and Wayland. So you can build native, non-decorated, native-looking things with X and Wayland. And that's what you see when you see me moving my pointer around those XI eyeballs tracking it in the thumbnails of a bunch of my videos. Those windows look so undecorated and plain, or they take on the host OS's widgetry, because X is very minimal, very minimal. And it's another one of those mostly happened by accident sort of things, a standard X11, video driver standard that kind of happened by accident, and it was finally put under the right license, and it set in, and it became popular for this sort of terminal-based graphics. There's been improvements since then, namely Wayland, which is much more high performance and modernized, and that's what Microsoft is going to be including, and that'll obsolete the way I'm showing you how to use graphics, but there's no problem. You just turn off the one line in your startup scripts and you start using the Microsoft stuff. That's the great thing about API compatibility. Oh, if I were to make a real subject to this video and put an edge on it, is that to be repurposable in your tech over the years, no matter the changes that are inevitable, because change will happen, is, for the most part, API compatibility, the desire for, and, the will to deliver compatible, love-worthy APIs over time. And then, no matter how the underpinning engines that things are actually wired to change, no matter how they gut things and pull things out and put other things in, you will always know the API to use it, and you will never be stuck high and dry with your skills going obsolete because that one specialized thing you really knew how to do went away. Like SQL will never go away, and I'll dust off my SQL chops and hop on the bicycle again, because it's worth doing. It's worth doing raw SQL, no matter what ORMs you use, object relational maps that keep you from having to write raw SQL, and no matter what, API mappings like a standard SQL dictionary to a SQL backend that can be used with import SQLite Dict, third-party libraries that you pip install. So if you pip install SQLite Dict, you can have the highly optimized P in the pool of tech component known as SQLite that ships as part of the standard Python library, back-ending your persistent dictionaries because of the ongoing will to make the Python dictionary the global API in Python to everything that needs key value interaction. And the details just change a little bit based on what you're connecting to. If you're connecting to something that has to be opened and closed, a file system with file write locks involved and temporary files involved, that basically have to know when you're done so that it can clean up after itself, or you have file leaks and memory leaks, you use something called the context manager, which is with open. So you would with open something off of the file system, and then you would pop the file handle off to the right. File handles, object and memory handles, variable names, references, pointers. There are so many sub-discussions I'd love to have here. But if you want to become a really advanced user of languages in general, and Python in particular, you want to look for when the file handle is popped out and figure out what the API to that is. So, if you're using something that provides a dictionary API, that is, a key goes in, a value comes out, that is back-ended by something that does file writing, then if you use it under the context manager, you will never actually have to implicitly close it. You will not have to do, handle name.close. It's just when it outdents from within that with open statement, it will do a finally close automatically. It's hidden syntactical sugar that Python provides so that your code gets shorter. If you use the context manager to provide you a file handler to something that uses the dictionary API, your knowledge and know-how will never go obsolete. This is kind of like piping in Unix, in the Unix shell system. The Unix operating system is what we're talking about, which became the Linux operating system through black box kind of copying. And the APIs are compatible, so the great confusion between whether Linux is Unix, and the answer is no, is the same API swapperoo magic that I'm talking about, so long as you have the very strong reasons to believe that these APIs aren't going to change. You are obsolescence, if not proof, then resistant. Python is just a whole grab bag smattering of these obsolescence resistant, love-worthy APIs. And that's the lesson of this video. What I'm doing with my video series is stripping it down to the least of that stuff that you need to do the most work without doing web development, without crossing over this line. Now, while it's true, we might write things that work as web servers and web services and microservices. The time will come where we write something that will listen on a port and will respond when a request is sent. I think I'm going to use 0MQ before I do that, though, as a practical alternative to messaging queues. Okay? So, in my small set of tooling, in my grab bag of things that I reach for in every project, I'll eventually get something that deals with inter-process communication, IPG, an old beloved Amiga thing that came along with a language called AREX, ported from an IBM Rex by Mike Sins, another guy I know. So I know the guy who wrote the Amiga operating system called Intuition, RJ Michael, who I'm in touch with in Facebook all the time. I get such a kick out of his postings. I'm in touch with the guy who wrote the language of choice for Amiga inter-process communication, Mike Sins, although he ported the Rex language from IBM. Still, I get a kick that I'm that connected to these things in whose traditions I fell in love, using Amiga DOS scripts under Intuition, using AREX scripts under Amiga interprocess communication, and now these days I'm discovering 0MQ, which is making the magic of Jupyter notebooks to real-time performance. If you're ever wondering how Jupyter Notebook is making the web browser behave the way it is, and Jupyter Labs, how servers are being run in the background really so very, very well to give you this browser-based Python experience that's being used as a primary development platform by people like me, then you got to learn a little bit about 0MQ, messaging queues that aren't. And that'll be in that short stack of tools, but it's kind of being thrown in there with Dask. I'm putting it in the I'll pull this out when I need it. I really don't need inter-process communication that much to put it ahead of named tuples. Named tuples are next up in my video series. I can't believe if anyone actually listened through to get to this point on this nearly hour-long video. But, you know, the anticlimactic conclusion to this all, after the discussion about, you know, mastering the correct API abstractions, that can't be obsoleted by time, so you won't be obsoleted by time, comes the important, you know, trees, you know, because we're talking about forests a lot, but when you zoom down to the tree level, the precise implementation I want to use everywhere where it looks like a nail, my hammer is named tuples. And named tuples, for anyone who hasn't been exposed to it yet, is one of those things that is not automatically loaded in memory like the primary data types of dictionaries and lists and tuples and sets, but actually has to be imported from collections. So from collections, import named tuple, all one word, all lowercase, singular, NAMEDTUPLE. Collections, all lowercase, plural. From collections, import named tuple. Then you can stamp out these little data object types, custom bundles of argument value pairs that give you much of the advantages of object-oriented programming without the overhead of object-oriented notation, having to use classes and having to dunder and knit and self-dot and all these things you have to really internalize in the OO style of design under Python, which does not come naturally. I'm starting to get my mind around it, starting to get a handle on it. However, named tuples are a completely another matter. You can just start using them to great effect immediately. And a named tuple is simply a pair of parentheses, and in between that parentheses is this equals that, and this other thing equals this other thing, spam equals eggs, foo equals bar, and of course you name the spam and you name the foo, and you don't name the eggs or the bar because those are the values that could be in those locations, right? So named tuples are tuples that have labels for the values in their sequential positions. So if it was an employee record, you would have the word employee, capital E, lowercase rest of it, open parenthesis, and then when you were defining it, you would have first name, comma, last name, comma, department, comma, extension, comma, email. And, you know, they have these conveniences where you just throw those into a string. And, I think there's another word at the beginning that repeats the employee because you need it inside the parentheses as well. But you Google the details. You create the pattern of a data type, and then you use that data type all over the place, and wherever you use it, it's self-documenting. It can be used in so many ways because that shape is reflective of so many things. It's reflective of arguments fed to functions. So if you want to feed a named tuple into a function as its arguments, you unpack it and align it to each of the function's inputs by splatting it in. You put a parenthesis before your named tuple variable name when feeding it as an argument, and it unpacks your named tuple content, your named tuple's contents into the input of the function. And if you do a double splat, asterisk, asterisk, it feeds it in as name value keyword arguments, a dictionary that's now available inside the function, so that you have key value pairs inside your function for using it. And this is exciting because there's other places that fit that same pattern of key value pairs, and that would be data records in a database. So you could say, insert this name tuple, and you just know how to pick it up and handle it. And when you have the variable name to reach inside to its different values, it's just dot this and dot that. So if you have an instance of one of these name tuples of an employee, it's, the name of the object. So, employee 1 dot first name, and you get the first name. Employee 1 dot last name. And that takes the place of the square bracket notation of, dictionary keys that are used so often in Python, where dot notation could also be used. But the Python API is hackable. So when you have a data type for which the dot notation is appropriate, the dot notation can be swapped in place of the dictionary key notation. And that is exactly what named tuples do, and it's another one of their conveniences you can take advantage of. And the list goes on. I could probably think of other examples, but I'm just about at my destination, and I should probably wrap up the conversation here, because I have made the decision that on my next video, I am going to illustrate all the wonderful attributes of named tuples and how that pattern is going to fit into almost every project, especially with this SQLite Dict persistent SQLite backed up dictionary strategy I'm using. Key value pairs, NoSQL. That means my keys I might want to have as multi-column primary keys as my index. And named tuples are a perfect candidate for that. But being an actual Python data object as they are, they can't just be used directly in SQLite Dict as keys, because keys have to be string data types. So you can pickle your named tuple. And so that's coming up soon. As soon as I do a project that has a data pull, I'm going to take the arguments that are used in whatever function does the data pull and make sure that those arguments are going to go in as a named tuple. And then I'm going to use those same named tuples as the keys in my key value pair persistent dictionary. But I'll have to pickle them to use them as the keys, because this particular API uses, and I've looked around, I've looked for better ones that natively support data objects, immutable data types like tuples as the keys. And even this project has experimented with it and taken it out. And when I saw the rationale of them taking it out, it's like, oh, well, then I'll do the symmetrical pickling and unpickling that they would have done in their code. It's just a little extra code on my side. It's like, does the code exist outside the package or inside the package? And if inside the package it caused complexity, they didn't need to deal with it. It's easier for them to just say arbitrary string. Any arbitrary string is the key. And leave it to people like me to figure out, oh, you can still use named tuples as your dictionary keys. You just have to pickle it going in. It provides all the same advantages. The B-tree, nested, optimized search, hash search that makes dictionaries so fast and makes probably SQLite. I'm not really sure of the technical details of their searches, but anything key-based is bound to be one of the modern optimized search patterns against keys and key value pair dictionaries. There's a hierarchical thing going on, divide by 2, and your search divide by, and it only takes a maximum number of steps, and that's where you get your deterministic predictability and how long a search is going to take, no matter how long your database grows. And it doesn't become much longer to do the search the longer your database grows, as intuition would tell you, because smart people figured out how to make it not take that long. And it has to do with how keys are used in key value pairs in systems like this. So the keys are going to be pickled names tuples. Whenever you look at them, they're going to be 100% explicit about what they are, what they're doing, how they're intended to be used, because of the built-in documentation of it's tuples with labels. And that's going to be the subject of the next video, when I actually probably will do a real data poll. Probably the Google Search Console data for my old abandoned sites expose a little bit of kind of shame how I let these sites go dead for so long, and even out of my control. In the case of Mike-Levin.com, Mike-Levin, or Mike-Levin, if you will, .com, I lost control of that to the Russian, AdSense spammers. I got it back since, but I never activated it. But there may be some interesting data there to pull. So at my destination, this is where I say goodbye. I rarely wrap it up quite so cleanly. I won't rhyme it. So thanks for joining me, and hope to see you again soon. And don't forget to subscribe.